In order to determine the load calculation without running new circuits, firstly, conduct a detailed survey. Interview residents to gather information about their equipment type, usage patterns, and any unusual loads. Inspect individual units to verify appliances and lighting installed. Obtain building schematics and specifications if available. Secondly, utilize demand factors. Apply demand factors to account for the likelihood that all appliances will operate simultaneously. These factors typically range from 0.5 to 0.8 for residential units. Thirdly, calculate the peak load. Multiply the appliance wattage by their respective demand factors and add the results to obtain the peak load. The peak load equals water heater wattage times demand factor, plus stovetop wattage times demand factor, and so on. Fourthly, calculate the continuous load. Use the calculation from step 3 to determine the continuous load, which is a sustained current drawn by the circuit. Continuous load equals peak load divided by the demand factor. Fifthly, adjust for multipliers. Apply multipliers for certain types of loads, such as air conditioners and lighting, as required by National Electrical Code. Sixthly, compare to the circuit rating. Compare the calculated continuous load to the circuit rating, which is 20 amps for number 12 wire. If the continuous load exceeds the circuit rating, there is a potential overload issue. Seventhly, evaluate actual usage. Since the customer has not reported any blown fuses, it is important to consider actual usage patterns. Determine the occupancy rate of the building. Observe the usage patterns of residents through interviews or monitoring devices. Check for any unusual or excessive loads that may not have been accounted for. Recommendations: if the calculated continuous load is slightly over the circuit rating but actual usage indicates no problems, consider the following options. 1. Monitor the circuit for any signs of overloading, such as frequent tripping or overheating. 2. Recommend energy-efficient appliances and responsible usage habits to reduce load. If the calculated continuous load significantly exceeds the circuit rating or actual usage indicates problems, additional circuits may be necessary. Demand factors are crucial in electrical load calculations, especially in multi-unit dwellings like apartments. They allow you to account for the fact that not all appliances and electrical devices will be operating at their maximum power consumption simultaneously. Without demand factors, you would have to assume that every device is running at full capacity, leading to an overly conservative and potentially wasteful design. The National Electrical Code (NEC) provides guidance on demand factors for various types of loads in residential buildings. These demand factors are based on statistical data and empirical observations of how electrical loads typically behave in real-world scenarios. Applying appropriate demand factors can significantly reduce the calculated load, potentially avoiding the need for expensive upgrades or the addition of new circuits. However, it is important to use these factors judiciously and to understand the specific characteristics of the building and its occupants. For example, a building with a high occupancy rate and a large number of energy-intensive appliances may require a lower demand factor than a building with a lower occupancy rate and more efficient appliances. There are several different types of demand factors that can be used in electrical load calculations. Some of the most common include general lighting demand factors, appliance demand factors, and heating and cooling demand factors. General lighting demand factors are used to account for the fact that not all lights in a building will be on at the same time. These factors typically range from 0.4 to 0.8, depending on the type of building and the lighting system. Appliance demand factors are used to account for the fact that not all appliances in a building will be operating at their maximum power consumption simultaneously. These factors typically range from 0.25 to 0.75. Depending on the type of appliance and its usage patterns. Heating and cooling demand factors are used to account for the fact that heating and cooling systems will not be operating at their maximum capacity at all times. These factors typically range from 0.4 to 0.8, depending on the climate and the efficiency of the heating and cooling systems. When calculating the electrical load for an apartment building, it is important to consider all of the different types of loads and to apply the appropriate demand factors to each. This will ensure that the calculated load is as accurate as possible and that the electrical system is designed to meet the actual needs of the building's occupants. In this specific scenario you presented, where each apartment is served by one 30-amp 240 volts fused circuit and one 20-amp 120 volts fused circuit, there are several factors to consider when performing the load calculation. Firstly, you need to verify that the existing wiring is in good condition and meets current safety standards. If the wiring is old or damaged, it may not be able to handle the calculated load, even if it is within the circuit's rating. Secondly, you need to carefully evaluate the actual usage patterns of the residents. As the customer mentioned that they haven't had any problems with blown fuses, it is possible that the residents are not using all of their appliances simultaneously or that they are using energy-efficient appliances. To get a better understanding of the actual usage patterns, you could conduct a survey of the residents to gather information about their appliances, usage habits, and any unusual loads. You could also install monitoring devices to track the actual power consumption of each apartment over a period of time. Thirdly, you need to consider the impact of any future changes in occupancy or appliance usage. If the building is likely to experience a significant increase in occupancy, or if the residents are likely to start using more energy-intensive appliances, you may need to adjust the load calculation accordingly. In addition to demand factors, there are other techniques that can be used to reduce the calculated load and avoid the need for new circuits. One technique is to use load shedding devices, which automatically disconnect certain appliances or circuits when the total load exceeds a predetermined threshold. Another technique is to install energy-efficient appliances and lighting, which can significantly reduce the overall power consumption of the building. Ultimately, the best approach to calculating the electrical load for an apartment building is to combine a detailed survey of the building and its occupants with a careful application of demand factors and other load reduction techniques. This will ensure that the calculated load is as accurate as possible and that the electrical system is designed to meet the actual needs of the building's occupants while also complying with all applicable safety standards and regulations. The problem you are facing involves a 1923 building with 23 apartments, each having a 30-amp 240 volt circuit for water heater, which is rated at 1500 watts, and a stovetop, which is rated at 840 watts, and a 20-amp 120 volt circuit for an air conditioning unit, which draws 5.2 amps, a microwave, which draws 6.66 amps, a refrigerator, which draws 3.75 amps, and receptacles and lighting calculated at 3 volt amps per square foot, resulting in 11.51 amps. The total calculated load for the 120 volt circuit is 28.4 amps, exceeding the 20 amp rating of the number 12 wire. The residents claim they have no issues with blown fuses. The county requires a load calculation before any further electrical work can be done. Here's how to approach the situation to avoid adding new circuits while ensuring safety and compliance. Firstly, verify the existing conditions and gather data. Conduct a thorough survey of each apartment to confirm the appliances present and their ratings. Sometimes, appliances may have been replaced with more efficient models. Check the actual square footage of each apartment to validate the receptacle and lighting load calculation. Confirm that the wiring is in good condition. Aged wiring can have degraded insulation, leading to lower ampacity. Secondly, apply demand factors appropriately. Demand factors are crucial for multi-family dwellings because not all loads operate simultaneously. The NEC allows for demand factors in dwelling units. Calculate the general lighting load, which is usually 3 volt amps per square foot. For small appliance circuits which are 2 or more 20 amp circuits, use 1500 volt amps per circuit. For laundry circuits which are 1 or more 20 amp circuits, use 1500 volt amps per circuit. Apply a demand factor of 0.35 or 35% to the feeder neutral load as per NEC section 220.61, which can reduce the calculated neutral load significantly. For electric ranges and cooking appliances, you can use NEC table 220.55, which allows for demand factors based on the number of appliances. Even if each apartment has a range, the demand factor for multiple ranges is substantially less than the sum of their individual ratings. For air conditioning and heating loads, the NEC allows you to consider only the larger of the two when calculating the service or feeder load, as they are unlikely to operate simultaneously. Thirdly, calculate the actual connected load. Using the surveyed data, calculate the actual connected load for each appliance and lighting. Convert all loads to voltamps for consistency, as power factor can vary. The formula for voltamps is volts times amps. For resistive loads like lighting and heating, watts equals voltamps. For inductive loads like motors, you may need to measure the actual power factor or use an assumed value. Fourthly, determine the continuous and non-continuous loads. Continuous loads are those expected to operate for 3 hours or more at a time. Non-continuous loads are those that operate for less than 3 hours. According to NEC section 210.19, branch circuit conductors must have an ampacity not less than 125% of the continuous load plus the non-continuous load. This means you must multiply the continuous load by 1.25 or 125% before adding it to the non-continuous load. Fifthly, analyze the 120 volt circuit load. The original calculation shows 28.4 amps on a 20 amp circuit. Analyze each component. Air conditioner 5.2 amps. This is a motor load, so it may have a higher inrush current, but the running current is 5.2 amps. Microwave 6.66 amps. Microwaves are typically used intermittently. Refrigerator 3.75 amps. Refrigerators run cyclically, not continuously. Receptacle/lighting 11.51 amps. This is where demand factors can significantly reduce the load. Sixthly, apply demand factors to receptacle and lighting loads. If the 11.51 amps is derived from 3 voltamps per square foot, this is a general lighting and receptacle load. The NEC allows demand factors for dwelling units. For the first 3000 volt amps, take 100%. For the next 9000 volt amps, take 35%. For over 12,000 volt amps, take 25%. Example: assume each apartment is 1000 square feet. General lighting and receptacles 1000 square feet times 3 voltamps per square foot equals 3000 volt amps. Applying the demand factor, the first 3000 volt amps is taken at 100%, which equals 3000 volt amps. Converting back to amps, 3000 volt amps divided by 120 volts equals 25 amps. However, with the demand factor applied, the first 3000 volt amps is taken at 100%, which equals 3000 volt amps. 3000 volt amps divided by 120 volts equals 25 amps, so it remains at 25 amps due to the 100% demand factor for the first 3000 volt amps. If the load exceeds 3000 volt amps, the demand factor would then apply to the portion exceeding this amount. Seventhly, recalculate the total load with demand factors. Air conditioner 5.2 amps. Use 125% for continuous operation, if applicable. Microwave 6.66 amps. Consider intermittent use, applying a smaller demand factor. Refrigerator 3.75 amps. Refrigerators cycle, so a demand factor can be applied. Receptacles/lighting use the demand factor calculated earlier. Total the loads with these adjustments. Eighthly, consider load diversity. Load diversity refers to the fact that not all apartments will draw peak power at the same time. This is another form of demand factor, but it applies to the entire building rather than individual apartments. If you have historical data on the building's power consumption, you can use it to justify a lower overall load calculation. Ninthly, document everything thoroughly. Keep detailed records of all calculations, surveys, and assumptions. This documentation is crucial for justifying your load calculation to the county inspectors. Tenthly, provide recommendations. If the recalculated load is still close to or slightly above the 20 amp circuit rating, recommend energy efficient appliances to the residents. Energy efficient refrigerators, microwaves, and air conditioners can significantly reduce the load. Install energy monitoring devices to track actual usage and identify potential overloads. 11th, explore load shedding options. If necessary, consider installing load shedding devices that can automatically disconnect non-essential loads during peak demand. This can prevent overloads without requiring new circuits. By following these steps, you can perform a comprehensive load calculation that accounts for real-world usage patterns and allows you to avoid adding new circuits while still meeting safety and code requirements. This approach should satisfy the county's requirement for load calculation and allow future electrical work to proceed. Remember to consult with a qualified electrical engineer to ensure that all calculations and recommendations are compliant with local and national codes. It is important to emphasize the accuracy of the survey data. Incorrect data can lead to inaccurate load calculations and potentially unsafe conditions. Ensure all data is verified and double-checked. Also, consider seasonal variations in load. Heating loads may be higher in winter, while cooling loads may be higher in summer. Account for these variations in your calculations. The age of the building and its electrical infrastructure is a significant factor. Older buildings may have wiring and equipment that are not up to current standards. A thorough inspection is necessary to identify any potential safety hazards. In addition to the steps outlined above, it's essential to communicate effectively with the residents. Explain the importance of energy conservation and provide tips on how to reduce their electrical consumption. By working together, you can create a safer and more efficient electrical system for the entire building. If the load calculation still exceeds the circuit rating after applying demand factors and implementing energy-saving measures, it may be necessary to consider alternative solutions such as upgrading the existing wiring or adding new circuits. However, these options should only be considered as a last resort after all other possibilities have been exhausted. Ultimately, the goal is to find a solution that meets the needs of the residents while also ensuring the safety and reliability of the electrical system. This requires a careful and thorough analysis of the situation, as well as a willingness to explore all available options. Remember that electrical work can be dangerous, and it's always best to consult with a qualified electrician or electrical engineer before making any changes to the electrical system. A licensed professional can help you assess the risks and ensure that all work is performed in accordance with applicable codes and regulations. Before starting any electrical work, it is important to notify the local building department and obtain any necessary permits. This will help to ensure that the work is done safely and in compliance with all applicable codes and regulations. It's also a good idea to inform the residents of the building about the planned electrical work. This will give them an opportunity to ask questions and express any concerns they may have. By keeping the residents informed, you can help to build trust and cooperation, which can make the electrical work go more smoothly. It's important to remember that electrical work is not a do-it-yourself project. If you're not a qualified electrician, it's best to leave the work to the professionals. Electrical work can be dangerous, and it's important to take all necessary precautions to protect yourself and others from injury. It is important to follow all safety precautions when working with electricity. These precautions include wearing appropriate personal protective equipment, such as gloves and safety glasses, and working in a well-ventilated area. It is also important to disconnect the power supply before starting any electrical work. By following these safety precautions, you can help to prevent accidents and injuries.